Hello, hello, hello. Welcome once again to Algebra 2. We're doing the same thing today, starting with a video that you guys are going to watch and take notes and follow along. So if y'all would start, please go ahead and copy down today's objective. I'll give you 30 seconds for that. And as you can see, today's objective is to find the x and the y-intercepts of a linear equation. We're finding the x and the y-intercepts of a linear equation. Now, before we start that, we got to go over some key vocabulary, some quick words that you got to know in order to be able to do today's work. The first one of those words is the x-intercept, of course, and the x-intercept is just the x-coordinate of a point where a graph hits the x-axis, where a graph intersects the x-axis. So if you look at this graph right here, this is the line x plus 2y equals 6. Okay. The x-intercept, in other words, the point where the line hits the x-axis is right here at 6, 0. 6, 0. Okay? So what we'd say is the x-intercept is 6. Okay? And we'd say that the line hits or intersects the x-axis at 6, 0. Okay? So you can see we have the y-axis here, the x-axis here. It's going to hit the x-axis at 6, 0. Take a couple seconds, copy that down. All right, the second keyword you got to know for today, we did x-intercept. The second keyword you got to know is the y-intercept. Okay? It's the same idea. The y-intercept is just the y-coordinate of a point where a graph hits the y-axis. So you can see right here, it's actually the same graph, but this time we're thinking about where this line hits the y-axis, the vertical axis. Okay, if it helps, maybe we can label our axes. That's the x-axis. This is the y-axis. So you can see this line intersects the y-axis at 0, 3. That means we go 0 to the left or right and 3 up right there. So we'd say the y-intercept is 3 because that's how high up on the x-axis the intersection happens. And we say that the line hits the y-axis or it intersects the y-axis at 0, 3. Okay. Take 30 seconds, get this down as well. Okay, hopefully you've got that down by now. So here's one of the big ideas that we're going to work with today. Okay. If you look at this graph, I've got a y-axis and an x-axis. In fact, let me label those. This is my x-axis. This is my y-axis. And here I've got two lines graphed. This is one of them, and this is the other. Okay. Now, when you look at these two lines, you can see really easily where their x-intercepts are. Okay. This is the x-intercept of this line. That's where it crosses the x-axis. And this is the x-intercept of the other line. That's where it crosses the x-axis. Okay. You can see the same for their y-intercepts right here and right here. Okay, this is the y-intercept for this line. Okay, so what you want to notice here is x-intercepts always have the coordinates something, comma, 0. Something, comma, 0. That's because whenever we have an x-intercept, we know that if we start at the origin at 0, 0, we're going to have to go either left or right to get to that x-intercept. And once we get there, we're not going to have to go up or down at all. That's why the y-coordinate of it is always 0. Okay, so x-intercepts always have the coordinates something, comma, 0. Y-intercepts, okay, for these, we're always going to have to go either up or down from the origin, either up or down from the origin, okay, and we'll never have to go left or right to get to the y-intercept. So y-intercepts always have the coordinates 0, comma, something. It means we don't want to go left or right, and then we do want to go either up or down, straight to the y-intercept. Okay, so go ahead, let's take 20 seconds to copy this down. Make sure you have this down pat. Okay, so in the past, we graphed a linear equation by getting it into slope-intercept form. That means if I gave you an equation that looked like this, 3x plus 4y equals 7, okay, we'd go ahead and write this again in slope-intercept form, which in general is y equals mx plus b. That's putting it into slope-intercept form. And based on that, we graph it. Now today what we're going to do is I'm going to give you some equations, and we're going to graph these, but we're going to graph them by finding the x-intercepts and the y-intercepts. That means the places, again, where the line hits the x-axis and the y-axis. And we'll see, we don't even have to take it out of standard form in order to do this. So let's see how we do that. Start with this one right here. Okay. We're going to graph 5x plus 2y equals 10 and find the x and y intercepts. Okay, now I'm going to do this in the opposite order. I'm going to find the x and y intercepts, and once I have those 2 points, I know I'm going to have enough information to actually graph the line. So let's see. First things first, I know that the x-intercept will always be in the form something 0. Okay, so that means the y-coordinate of the x-intercept is going to be 0. So if I want to find out what the something is, what its x-coordinate is, all I have to do is take that original equation and plug in 0 for y, and then I'll solve for x. So let's see. 5x plus 2y equals 10. Let me plug in 0 for y. So 5x plus 2 times something equals 10. Well, 2 times 0 is, of course, 0. It's 5x equals 10. And I'll divide both sides by 5 to finish solving for x. 10 divided by 5 is 2. That's the something we were looking for. Okay, that's the something. In other words, that's the x-coordinate of the x-intercept. That means that the x-intercept is 2. And the intersection point is 2, 0. Now we can do the same thing for the y-intercept. Okay, let's see. For the y-intercept, remember, for the y-intercept, that means we're going to have to go up or down, but we won't have to go left or right at all, because the point that we're looking for is right on the y-axis. So for the y-intercept, it's going to be 0 something. So in this case, I can plug 0 in for x in order to find what that something is for y. So let's see. We'll start with our same equation. 5x plus 2y equals 10. We're going to plug in 0 for x. 5 times 0 plus 2y equals 10. Well, 5 times 0 is 0. So all we're left with is 2y equals 10. We'll divide both sides by 2. Y equals 5. Okay, and again, this right here is the something. That's the y coordinate. So in this case, the y-intercept is 5. And the intersection point is 0, 5. Okay. Now at this point, we're actually ready to graph this equation. We're ready to graph this equation because look, we have 2 points that are on the line. So let me take out my graph paper. You all can do this in your source books. Take out my graph paper and let's see what we have here. Okay. The first point we found was 2, 0. That means go to the right by 2 and then up by 0. That was the x-intercept. So start at the origin, go over 2, and then up 0. The point is right there. Okay. The next point we found was, let's see, 0, 5. That means go left or right 0 and up 5. So left or right 0. No, we don't go left or right at all, and we go up 5. 1, 2, 3, 4, 5. Those are the 2 points for our line, and we'll connect them. And again, this is our x-axis, and this is our y-axis. Notice how I have the arrows on either side. One last thing we can do that's nice is we can label these x-intercepts. Okay, this is 2, 0, and this is 0, 5. And we can label the actual line itself. The equation of this line is 5x plus 2y equals 10. Okay, so what we did here is we found the x and y coordinates. All right, the idea is we know that the x-intercept has to have the coordinates something, 0, and so we plug in that 0 for y. The y-intercept has to have the coordinates 0, something. And again, that's because it's on the y-axis. Okay, let's try another. Okay, we want to graph y equals 2x minus 3 and find its x and y intercepts. Okay, so let's start the same way. First, we'll find its x-intercepts. Okay, now remember, the x-intercepts are on the x-axis. That means that their y-coordinates are 0, because you don't have to go up or down to get to them. So its coordinates are going to be something 0. Okay, so that means, look, 0 is in our y-coordinate there. We'll plug in 0 for y. So let's see. We start with y equals 2x minus 3 to begin with, and we'll plug in 0 for y. 0 equals 2x minus 3. Okay, we need to solve for x. So to do that, we first have to deal with this minus 3. Add 3 to both sides. On the right-hand side, we have 2x. On the left-hand side, we have 3. Okay, now we have 2 times x, so we'll divide both sides by 2. On the right-hand side, we have x, and the left-hand side, we have 3 halves. Let's see, can we simplify 3 halves at all? Are there any numbers that go into 2 and 3? Nope, no numbers other than 1. So in this case, the x-intercept is 3 halves. And that means that the point we'll graph is 3 halves, 0. Again, we'll do the same thing for the y-intercept. Because the y-intercept is on the y-axis, that means that its x-coordinate will be 0. Okay, because we don't have to go left or right to get to a point on the y-axis. That's the up and down axis. Okay, so it'll be 0, something. So again, we'll start with our original equation, y equals 2x minus 3, and let's plug in that 0 for x. So y equals 2 times 0 minus 3. Okay. 2 times 0 is 0, so with y equals minus 3. So that means the y-intercept is negative 3, which means the point we'll plot is 0, negative 3. Okay. So now we have the 2 points that we're looking for, the x-intercept and the y-intercept, 3 halves, 0, and 0, negative 3. So we can go ahead and graph those. Okay. I'll write those 2 points on this paper so they're easier for you to see. Those 2 points were 3 halves, 0, and 0, negative 3. Okay, let's start graphing them. First things first, 3 halves is the same thing as 1 1/2, or 1.5. If you want, you can take your calculator, check that for yourself. 3 halves, 1.5. So, for this first point, we're going to travel 1.5 in the x direction, and then 0 in the y direction. So it's just between 1 and 2, right there. For the second point, 0, negative 3. So 0 left to right, and then 3 down. 1, 2, 3. 1, 2, 3. Okay. We'll connect our 2 points. Again, notice the arrows on the ends. Let's see. The equation of this line, if you check back in your notes, was y equals 2x minus 3. Okay. This point was 0, negative 3. This point was 3 halves, 0. This is the x-intercept, and this is the y-intercept. X-intercept and the y-intercept. Now, one thing you should notice about this, the last problem we did, I gave it to you in standard form. This one I gave to you in slope-intercept form. Okay. That didn't really change the process at all. We knew, I'm going to go back to this, we knew what the coordinates of our x-intercept and our y-intercept should look like. Something comma 0, 0 comma something. Okay. So we knew all we got to do is plug in whatever coordinate we know into the equation and solve for whatever's left. Okay. I'm going to give you 25 seconds to finish up your graph if you're still going. Okay, let's move on to a couple more real quick. 2x plus 5y equals 10. We're going to find its x and y intercepts. Let's do it the same way. Okay. First, we'll deal with its x-intercepts. Okay, we know, again, for x-intercepts, they're on the x-axis, so we're going to have to go left or right. So we don't know yet what the x-coordinate is. But we do know we're not going to have to go up or down. So the y-coordinate is going to be 0. So 2x plus 5y equals 10. We'll plug in 0 for y, because that's the one we know. 2x plus 5 times 0 equals 10. Well, that's 2x equals 10. Okay. We'll divide both sides by 2. X equals 5. And that 5 is the something we were looking for. So the point we're looking for here is 5, 0. Now let's do it for the y-intercept. Again, here, for the y-intercept, we know we're not going to have to go left or right at all because it's on the y-axis. So the x-coordinate, which controls left or right, the x-coordinate is 0. The y-coordinate, we don't know yet. So it's going to be something. 2x plus 5y equals 10. Okay, we'll plug in 0 for x because that's the one we know right now. 2 times 0 plus 5y equals 10. Well, 2 times 0 is 0. 5y equals 10. Divide both sides by 5. Y equals 2, which means this is the something we were looking for. So our point here is going to be 0, 2. Okay, I'll leave it to you guys to graph that. We'll move on. Let's graph 3x minus 2y and find its x and y intercepts. Okay. Same as before. I'm going to give you guys, let's see, 2 minutes to find me the x and y intercepts here.
Here's what I got. 4 in the equation, that means you have a vertical line. Okay. That means that this is vertical line. Okay. It's a vertical line at x equals 1. So going back to this graph paper, okay, suppose I have my x-axis and my y-axis. Okay. X equals 1 means show me a vertical line at x equals 1 on the x-axis. That means right here. That's what this line looks like. My line's kind of wobbly. Hopefully you used a straight edge. So now think, what's the x-intercept of this line? Where does this line hit the x-axis? Right there. So the x-intercept is x equals 1, which happens to be the same as the line itself. In other words, 1, 0. Now the question is, what's the y-intercept? Where does this line hit the y-axis? Hopefully the answer you can see is there is no y-intercept. This line never hits the x-axis, or excuse me, the y-axis. Vertical lines do not hit the y-axis. Okay, so it's a little bit of a trick question if somebody asks you for the y-intercept of a vertical line. And again, this line, the equation for it is x equals 1. You can see there's no y in that equation for that line. Let's take one more. Okay, let's graph the line y equals 4 and find its x and y intercepts. Now this one is also a little bit different. This is y equals negative 4. Y equals negative 4. Okay, there's no x anywhere in the equation for this line, but we still have to find its x and y intercepts. So let's go ahead and for this one too, let's skip straight to graphing. Skip straight to graphing. We're trying to graph the line, let's see, y equals negative 4. Okay, that means show me all the points that have the y coordinate, negative 4. Okay, well let's see. 1, 2, 3, 4. This is negative 4 right there. Okay, so this point is 0, negative 4. Okay, this point also has a y coordinate of negative 4. So does this one, and 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 so on. So hopefully what you can see right here is we actually have a horizontal line. It's a horizontal line through all the points that have negative 4 as their y coordinates. So this line right here is actually y equals negative 4. Okay, so the question is, first, what's the x-intercept? Where does this line hit the x-axis? And the answer, as you can hopefully see, is there is none. This line is parallel to the x-axis, so it'll never actually hit it. What about a y-intercept? Yeah, it's right there. The y-intercept is at y equals negative 4. In other words, that point is 0, negative 4. Okay. So those last two cases, vertical lines and horizontal lines, a little bit different. Okay, now before you guys get going on your problem set, I want to throw a few quick shout outs out. First period, Bernie, keep doing what you're doing. Keep up the good work. Respect. Young Chris. Shout out to my man, Young Chris. All right. Let's get going, folks.